Okay, today we're going to talk about compound inequalities, so make sure you add in your title, your learning target, your date, and your page number. And you add it into your table of contents. Okay, so a compound inequality is just more than one, so we're dealing with two inequalities at a time. And these two statements are usually separated by the words and or. Okay? If the inequality is an and statement, think about what the word and means. And means both. So the inequality has to satisfy both things. Okay, and all this will make sense in a minute, but this is the part that's shaded by both parts of the graph. Where or, it doesn't matter which one, it's the things that work for either or. So for either inequality. So this has to be both, this has to be either. Okay, so a lot more things are going to fall under the or category, and we'll talk more about that later. Okay, so we're going to write an inequality that represents this set of numbers and then graph it. So all real numbers, which would be x, are greater than 0. So I'm going to write that out. X is, I'll do it in a different color. All real numbers that are greater than 0. So if I wrote that out, I would write x is greater than 0. And all the numbers that are less than or equal to 4. So if I wrote that, x is also less than or equal to 4. So let's graph it. If I was going to graph the first part, x is greater than 0, it would be an open circle at 0, and I would shade to the right. That's what we've been doing. That's not new. Okay. Then I have x is less than or equal to 4. If I did that, then it would be a closed circle here, and it would be going this way. Now, what I just told you is that if it's an and statement, then it has to satisfy both things. So I'm going to erase the part of the graph that doesn't satisfy both things. And this is what my final answer graphed should look like. Okay? So that means it's between 0 and 4. It can't actually be 0, but it can actually be 4. So let's write this in a better way. If it's an and statement, what you're going to do, because it's shaded in the middle, is write your x in the middle. I'm going to write the bigger number on this side and the smaller number on this side. And I'm going to say, okay, well, x has to be bigger than 0. So that's eating the x, and that hasn't changed. It was eating the x here. So x has to be bigger than 0, but smaller than or equal to 4. So this is your final answer. This is your final answer graphed. And now if we were going to write that in interval notation, remember we write the smallest number first. It never goes less than 0, so it's going to start here. And then we're going to put a parenthesis because it's an open circle. That's not new. And it goes all the way up to 4, never goes past that. So the highest it goes is 4. And then we're going to use a bracket because it's a closed circle. That's not new either. So this is your answer written. This is your answer graphed. And this is your answer in interval notation. Let's try it with another example. All real numbers that are less than 0. So let's start with that. X is less than 0. Okay. So, or, that'll be important later, greater than or equal to 5. So x is greater than or equal to 5. Well, let's graph each of those things. Open circle at 0, and it's going this way, because this is where everything's less than 0. Closed circle at 5, and it's going this way, because this is where everything's bigger than 5. Okay, we've talked about this earlier when we talked about and versus or. And meant it had to be shaded by both. But it doesn't say and, it says or. So either thing can be satisfied here. So this is the graph. Okay? It's got both of them here. So when I write my answer, they can be written as two separate things, just like I got two separate graphs for an answer. So when I write my answer, it would be x is less than 0 or x is greater than or equal to 5. So that's how you write your answer. This is how you graph your answer. Now let's talk about interval notation. The number that goes left forever is negative infinity. And then it comes all the way up here and it stops at 0. And we would put a parenthesis. Okay, we have to show that there's not stuff here. We can't just say it goes from negative infinity to positive infinity, because that would mean that all this is shaded in, and it's not. So now we're going to put a U, and it means in union with. So it just means that the graph picks up. So it picks up again at 5, and that's a bracket because it's a closed circle, and it goes off to positive infinity. So this is what it looks like in interval notation. This is what it looks like graphed. This is what it looks like written. Let's practice solving them. When you solve them, you're trying to get the variable by itself. So look at this. This is going to be an AND statement, and I can tell that by looking at it because my variable's in the middle. It has to be the thing that's satisfied by both. So you're just going to solve your equation. See my equal signs, my inequality signs, that's where we draw our lines down. And you're just going to try to get the variable by itself in the middle. So I need to get rid of minus 4. And in order to do that, I'm going to add 4. But instead of adding it to both sides, now I've got 3 sides. So you're just going to add it to all 3 sides. Negative 3 plus 4 is 1. That cancels and leaves me with m. Negative 1 plus 4 is 3. And I didn't multiply or divide by a negative number, so my signs are going to stay the same. So let's look at my answer. Let's start with graphing it. It's going to be a closed circle at 1. And notice that m is bigger than that, so I'm going to go this way. It's going to be an open circle at 3, and notice that m is smaller than that, so I'm going to go this way. So that's your answer graphed. So written, graphed, and let's do interval notation. The lowest it goes is 1, it's a bracket because it's a closed circle. The highest it goes is 3, and it's a parenthesis because it's an open circle. So there's your answer written 3 different ways for that one. Or statements are actually easier because, like I said, you graph them separate, which means you can solve them separately. So they're going to be 2 different equations, and I'm just going to solve them as different equations. I'm going to start with this one. Well, if I'm trying to get t by itself, I would subtract 2, 3t is less than negative 9, divide by 3, divide by 3, t is less than negative 3. I divided by a positive number so I didn't have to flip my sign. And I can go ahead and graph this and graph my answer because it's not going to change anything. What my answer is on the other one's not going to make a difference because it's an or statement, because they don't depend on each other. Okay, so let's do the other one. Trying to get I'm trying to get 4t by itself. So I'm going to subtract 5, those cancel, I'm left with negative 4t is less than negative 4, divide by negative 4, divide by negative 4, t and 1, and I had to flip my sign because you see where I divided by a negative number. So when I graph it, open circle at 1, and it's everything bigger than that, so I'm going this way. So my final answer written would be t is less than negative 3 or t is greater than 1. This is what it looks like graphed, and if I did interval notation, the lowest it goes is negative infinity, 3 with a parenthesis because it's an open circle, in union to show that it picks up and it doesn't go, it's not continuous through here, 1 to positive infinity. Okay, so make sure you answer the question, and if you can't, that you rate the video.